you. Do you believe that AM for plastic parts has developed faster than AM for metal parts? And why do you think this is happening? And are certain market applications driving this trend?
Well, I think additive manufacturing has taken off more for plastic parts than metal so far. But that's probably, I think, due to the machines that have been available over the last 10, 15 years or so on. I mean, it's only fairly recently that we're able to get pretty good quality metal parts directly from an additive manufacturing machine, whereas we've been able to do that with, say, selective laser sintering for quite a long time. So I think there's more experience of getting good quality parts from plastic machines than there is metal. But that is changing now, so it's now possible to get really good metal parts from a laser fusion machine, for example, or an electron beam machine. So I think it will balance out over the next few years, and I think you'll probably see rising numbers of metal parts coming from machines. The issue you've got, I think, is that metal processes tend to be a bit slower than the plastic processes, so there's a cost issue there still.
Yeah, I would add that one of the reasons why polymers has perhaps been adopted so much more quickly, or apparently more quickly, is because of the cost of entry for doing that as well. It's relatively low cost. They're normally for relatively low risk parts, not safety critical parts. That the market for those type of parts is broader. But certainly from my own experience, I can say that the investment in equipment to manufacture and process polymer parts is certainly a lot less than the infrastructure you need for metals. I think the downside of that, though, is that because of the relatively low cost of entry, just about anybody who's got a bit of cash in their pocket can go and buy a 3D printer of some sort, and that has really hurt the credibility of the process, and very much been seen as a prototyping or a sort of a maker type process. And actually, the really sort of high-end engineering plastics that can be manufactured in some of these parts are very good and have very good applications. So it hasn't had quite the same hero status that sort of utopia of printing metals has been. But certainly its own sort of Achilles heel is the fact that it's relatively low cost to entry.
Yeah, I totally agree with you, Kieran. It's the low cost of entry. It fires up some application areas because people can try it really, really cost effectively. But the number of potential customers that I talk to about sort of supplying them with parts from our powder bed process say, oh, we've got a 3D printer, we prototype on that. Yeah. I generally say to them, I'm not looking to replace your in-house prototyping machine, because that's fast turnaround stuff. I'm talking about higher volume and higher quality, but they still struggle to understand that there's a difference between a £1,000 FDM machine and a £200,000 laser bed machine.